All right, ready for a deep dive. We're tackling microservices today, breaking down this whole architectural style everyone's going on about. And hey, we've got a roadmap this article, a pattern language for microservices.
It's a gem, really, not just what microservices are, but how practical patterns for making them work.
Love it when a plan comes together.
Mhm.
Okay, imagine. Your business, right? Big, old, monolithic application. Think of it like, I don't know, a huge factory, everything in one place. Works, but updating, scaling, nightmare without things going haywire. Now enter microservices or agile adaptable city. What's the visual here?
Okay, so instead of that one massive app, you split it up. Smaller, independent services, each handling a specific job. It's like swapping that factory for a bustling city, specialized districts all working together.
From one-size-fits-all factory to a dynamic city with its own districts. What's the upside for businesses making this switch?
Flexibility, for one. Need to update one service. Go for it. Doesn't impact the others. Big traffic spike. Scale up just the services, feeling the heat. It's adapting on the fly, basically.
Sounds like a dream, honestly. But taking a monolith and carving it into these independent pieces, that can't be easy. Where do you even start?
Yeah, not as easy as drawing lines on a map. The article lays out some strategies. One is decompose by business capability. Basically, what are the core functions of your app order processing, user stuff, inventory, whatever? Build services around those.
So each service is like a specialist in its own little world. What else?
There's decompose by subdomain, which fits with domain-driven design if you're familiar. Dividing the app based on areas of expertise, essentially. Now, say you want to transition gradually, not rock the boat too much. That's where Strangler application pattern comes in.
Strangler application, intense. That's some digital hitman taking out the monolith.
Not quite. More graceful. Instead of rewriting everything at once, you replace parts of your monolith with microservices, bit by bit, like vines slowly taking over a structure. Smoother, less disruptive.
Okay, less demolition, more strategic overgrowth.
Yeah.
Gotcha. But with all these separate services, how do you make sure the data they use stays consistent? It's like
Aye.
making sure every district in our city has the right maps and info, right?
Right, and it's a challenge. One approach is the database per service pattern. Each service gets its own private database. Good for isolation, but then you need to keep all those separate databases in sync.
So if one service updates something, got to make sure that change goes everywhere else too.
Yeah.
What's the alternative?
You could do a shared database, all services tapping into the same one. Seems simpler, but you risk tight coupling between services, which kind of defeats the whole independent thing.
Like having one giant city hall instead of those distributed local offices? Makes sense.
Exactly. It's about finding the right fit for your specific setup. There's no one-size-fits-all.
So if it's not a shared database, how do these services even talk to each other, stay on the same page? No carrier pigeons involved, I hope.
No carrier pigeons, thankfully. We've got two main ways, synchronous and asynchronous communication. Think of it like needing something right now, you'd make a phone call. That's synchronous, like remote procedure invocation, RPI, and microservices. A service makes a request, waits for the answer.
Immediate response needed. Makes sense. What about when it's not so urgent?
Then you send a letter, right? Don't just stand there waiting for the reply. That's asynchronous, often using a messaging system. Services send messages without blocking each other, more flexibility.
So in our city, RPI is the phone call. Asynchronous messaging is more like postcards. Gets there eventually.
And just like in a city, choosing which communication method depends on the situation. Sometimes you need that instant answer, sometimes you can be more laid back.
We're really painting a picture here. Benefits of microservices, ways to break down applications, how they handle data, talk to each other. But with all this going on, stuff's got to go wrong sometimes, right? How do you even manage, keep track of it all? Need an air traffic control tower for the city of ours.
You got it. Managing a microservices ecosystem. It's like air traffic control in a busy city. That's where those advanced concepts come. Service discovery, distributed tracing, and health check APIs. Like I said, our air traffic control.
Okay, so service discovery, what am I picturing here?
Yeah.
A giant directory, always updating with where each service is. How does that actually work?
You're on the right track. Services pop up, go offline, maybe move as they scale. We need a directory that keeps up with that service discovery. It's that central registry, keeping tabs on available services and their locations.
So if one service needs to, say, process a payment, it checks service discovery to find the payment processing service wherever it is right now.
Exactly. Streamlines communication, keeps things moving in our microservices city.
Hmm.
But finding each other's just the start. Imagine a package going through different carriers across multiple cities. That's the kind of complexity we're talking about when tracing issues in microservices.
Sounds like a logistical nightmare. That's where distributed tracing swoops in.
Yeah. Exactly. Our secret weapon for debugging in this kind of system, with distributed tracing, we follow a single request through all the different services it goes through.
Like slapping a tracking number on that package.
Yeah.
We see exactly where it goes, when, and if there are any hiccups along the way.
Precisely. Timestamps, service names, errors, the whole shebang. We can spot bottlenecks, troubleshoot problems much faster. But even with great communication and debugging, we need to make sure our services are healthy and working in the first place.
Regular checkups and maintenance for all the buildings in our city. That's what health check APIs are for.
Exactly. Think of them as routine checkups. But for our microservices, are they responding on time? Connecting to the database? This helps us catch potential issues before they blow up.
I'm sensing a theme here. Early detection is key with microservices, like having smoke detectors and sprinklers, instead of waiting for the whole building to go up in flames.
Yeah.
But what about security? With all these separate services talking, sharing data, isn't that asking for trouble? You're right about that. It's like we've built this amazing city, but now we need to make sure it's safe and secure, not just walls around each district, but managing how everything moves between them.
Exactly. And like any city, security in microservices has a lot of angles. Authentication, authorization, encrypting, data vulnerability scanning, you name it.
Where do you even start? It feels overwhelming.
It can seem that way, but a good approach is layered security. Multiple lines of defense. Think API gateways for security at the edge, service-to-service authentication to control communication between services, encrypting sensitive data both when it's stored and when it's moving.
Like security checkpoints, ID cards, and secure communication channels within our city. Each layer makes it that much harder for something to slip through.
Exactly. And just like a city constantly updates its security to stay ahead of threats, we need that same mindset with microservices. Always assessing, adapting, improving.
So it's not just about new tech. It's a whole new way of thinking.
Yeah.
A new way to build and manage software.
You got it. Microservices are a huge shift from those old monolithic architectures. It changes not just the tech, but the teams, the processes, even the company culture.
Like going from a traditional factory where everything's controlled to a city that's dynamic and figures things out as it goes. Both have their place, but that city needs a different approach.
For sure. And just like a city thrives on its different districts having their own specialties, microservices let us build systems that are more modular, adaptable, and resilient. But that agility means we need to manage complexity and make sure things are secure across the board.
Well said. So we've gone on this deep dive into microservices.
Yeah.
And it's clear they've got huge potential for the future of software. But it's not a magic solution. It's a journey that needs planning, learning, and being open to new ways of doing things.
Absolutely. And if you're starting this journey, remember to start small, focus on clear services, prioritize automation, and never underestimate communication, data management, and good security.
Great advice for navigating this exciting and always changing world of microservices. And to our listeners, as you explore this landscape, we'll leave you with this. How can we use the power of microservices to not just build better software, but to create organizations that are more agile, adaptable, and resilient organizations that can thrive in this complex and interconnected world?
That's the question we should all be thinking about. Until next time, keep exploring, keep learning, and keep diving deep into the world of technology.